Kristina Havas, and I was an EMBL iPod Fellow here in EMBL Rome from the years of 2012 to 2016 in the lab of Martin Jecklinger. Since then, I've now moved to Milan, where I have my own group at EFROM, the Institute of Molecular Oncology, where we've kind of continued along a lot of the same research lines which were initiated here, or were inspired by the work here, as well as being inspired now by my current microenvironment.
What brought you to the EMBL? How did you get to know the place? How it became a work opportunity? What's the story there?
So of course I did my PhD. I'm American originally, but then I moved to Scotland to do my PhD. And during my PhD, of course, I came to know EMBL because I was doing my PhD in epigenetics. EMBL had this huge chromatin meeting that was like a must-do, and so during my PhD, EMBL was already an organization that I was familiar with. And then following my PhD, actually I have a very different career path. I left research for a while. I moved to Italy for personal reasons, and I had a family, and so once I had my family up and going, I started missing research. I came back into research in a very small way here in Italy, and I was just looking for opportunities to really try to grow again. And at that point, I came to know about EMBL Rome and the iPod program, and I was fortunate enough to apply and make it into it. And this is really where I believe my scientific career actually started, because at this point it was a real choice I made to come back into this world, and I couldn't have been luckier to come back in within this EMBL Rome community.
So what did you find here at the EMBL when you came? I mean, we have been discussing with Nadia Rosenthal about the project of having a site of mouse biology. What was your feeling? I mean, did you like it? Did you find it was a small institute? What was your impression, first impression, landing on the EMBL galaxy?
So I think anybody who's ever come to EMBL Rome will know that it's a very different reality to many of the other EMBL sites, but it's a little bit smaller. When I joined EMBL here in Rome, there was no real research focus for the Institute. We were all just using mouse models. But I think these are things that made this place very, very special. And so when you first joined here back in 2012, with this great mix of different scientists, had a real family feel to the place. So we came in, there was a wonderful community. We had everything we needed to have to do the science that we needed to do. And it was very inspiring, I think, in part because it was so diverse. You might have believed that you were in an institute that wasn't able to do the same level of science as maybe what was done in EMBL Heidelberg, just because the infrastructure and the size. But in reality, the science that was done here in that period was really, really outstanding. Mm-hmm. And so
So do you think it was because it could take advantage of all the support and the central facility and the scientific connections, or
I think
it was mostly because it was a good combination of scientists?
No, I mean, having access to all those things makes a difference, of course. But day to day, I think what made the difference was that it was an active and engaged scientific community here on campus, and there was a lot of support from direction for the activities we're doing. I mean, I'm speaking as a former postdoctoral fellow. I felt a lot of support and encouragement and excitement around what was being done. So although we felt part of the EMBL sphere, I don't think that what made it possible was being a part of that. It was actually the local community, which is very inspiring.
So I mean, and you mentioned that your career in science had been also posing for family reasons, and I was wondering if you can reflect on whether the EMBL was helpful in balancing family and science. I mean, was there particular support that you didn't find elsewhere? Or I mean, did you then?
I believe that there is support. I mean, in terms of help with the creche and things along those lines. At the moment in which I joined, I would say it was not as much of a factor. What made the big difference for me was being, number one, given this opportunity, and being in an enabling environment to really like kind of let my potential reach its full potential.
And scientifically, I mean, I know that you are involved now in cancer research. So was it already a focus? I mean, did you have a strong impression on or idea of where you wanted to go back then, or not?
Well, I applied to a project which was very cancer focused, and so the projects I applied to in Martin's lab was trying to understand mechanisms of therapeutic resistance in breast cancer, which is, you know, a very horrible aspect of breast cancer. The fact that women who believe themselves to be cured can actually reoccur 15 to 20 years later, and we still don't really understand the mechanisms which lead to those reoccurrences. And so I applied to EMBL. I applied to a program where we were specifically going to be focusing on cancer biology. I have to say, as a scientist, I like to consider myself a little bit more fundamental in terms of my approaches, although I believe that something like 99% of therapeutics which make it to market today are based off of basic research. I believe that it's really important to fund and support basic science, understand basic mechanisms that can eventually lead us in that direction. My background wasn't necessarily cancer biology. I just like the questions that you can ask within the context of that model and hope that you can make a difference someday.
Yeah. No, but then certainly the problem, I mean, you were making the point of fundamental biology, but I think, you know, in the specific idea of finding, you know, what are the mechanisms of resistance to a drug, the way forward would only be fundamental biology, right? I mean, you have to understand the processes in order to understand what is going on. So do you still work on that aspect, and are you moving towards more practical issues, or going forward you want to be still in the fundamental biology area?
Well, I like asking really apparently simple questions, and so I enjoy working more among these fundamental questions. So nowadays we're asking questions about what are some of the, you know, the tumor the ecological niche of a tumor, what is it, and what are the interactions which help form it. We're asking questions about how the biophysical properties of the cell and the environment can impact upon the physiology of the cell and the tumor itself. And so we're still asking very, very fundamental questions. The harsh reality is that funding is not easy. And so if you want to ask fundamental questions, you very often have to place it within the context of a disease, because funding for the pursuit of knowledge for the sake of knowledge is very, very difficult to find, particularly here in Italy. And so we are, of course, always focused on how our research could be leveraged to develop further understanding of our disease models, in this case cancer. But I still am very fairly committed to asking basic questions.
So, but I think one of the, you know, possibilities with fundamental biology is, and the scarcity of funding is essentially, you know, to question always whether, for instance, you're using the right system. And, you know, mouse is a very, impactful system, also from the point of view of resources, is live, is an animal. So do you think, you know, the research to answer this question always need this kind of setup, or do you think it's something that in the future can be done you know, with simpler and cheaper systems? I mean, now we've seen a lot of blooming of organoid research. Are you considering some of these, or you think, you know, there would be always a place for mouse biology?
So, I mean, while I was here at EMBL, my project really used a mixture of mouse models and organoids that were developed from those mouse models. And so I guess my background would be in kind of simplifying a complex system through the use of organoids. Since moving from here, I have to say that we do a lot of cell line work. We use iPS-derived cells. We use cancer, like primary and cell line derived cancer models. And so we really try to cater our model system to the question that we're asking and the tools that we have to answer the questions. Mice are a very, very powerful system, but then when you go to publish, they ask you for the human data. And so it's like, you can have all this beautiful characterization of a mouse model, and then they say, and at the human level, what's happening? And so then you have to go to the pathologist and get the human samples. And so I think that you have to think hard about the question you're asking, the tools that you have at your disposition, the money you have, because mouse models, organoids are very expensive systems, and whether or not it's necessary to answer those questions. I think that today it's super unfortunate that to get into the high-level journals, if we're thinking about, you know, the scientific career and the necessity to publish and publish well, that they often are asking for more and more complex model systems or more and more advanced technological settings. And I think that that's one of the big driving factors towards using these models as well, because you're pushed to show that you have that kind of relevance, which you know, is of course important, but also a little bit, I guess it kind of pigeonholes the number of groups which are able to make it to that level in terms.
Sure, I think this is a fundamental problem now because, again, you have said it yourself, resources are scarce, and so if you have like a system that is driven towards investing more, you know, the demands of the journal. So there should be, of course, a little bit of a way out, not really to the past, but perhaps you know, forms of reporting science that are less you know, demanding. So do you have, you know, thoughts in this? What would you think would be a good way to go forward? I mean, there's many problems, right? You know, papers are taking too many peer reviews and reviews in order to be published, then they have to involve a lot of data. So do you have an idea of how we could reform this system?
I mean, I think a lot of people have been working really hard on ideas on how to reform the system. Potentially bioRxiv is one of the bigger steps forward that we have in this, which is much more similar to what's done in the physics community, where they have like this more open source pre-peer reviewed systems which are available to disseminate your data. This seems to be working, right? It's a way to get your data out, get feedback on it before maybe making it to publication. The reality is it's very difficult to change a system which has so embedded in the structure of how science works. But I believe that these nowadays, with the use of these more social networks for advertising your work, as well as these platforms like bioRxiv that allow these non-peer reviewed works to get out and essentially, when it works, have a peer review per se, without going through a journal, are steps in the right direction.
And I mean, I was curious about, I mean, you were saying yourself, I mean, you started a family, and I think, you know, one way to inject more resources in science is actually providing, or, you know, a culture to the new generation that science is important and fundamental science is important, that you know, this is, you know, for the progress. I mean, is it something that you think in your, you know, in your practice? I mean, are you passionate about communicating science? Are you involved in that?
No, I think it's absolutely essential. But beyond communicating science, we need to get these young people into the scientific environment. They need to get their hands wet. I mean, growing up in the States, we had science labs in the school, we had the Westinghouse competition, we had science fairs, and so we were engaged in more practical science from a very young age. Here in Italy, and I don't know about Europe as a wider, on the whole, there's very little practical exposure to science labs. And so I am like the first, whenever somebody writes to me and asks, like, can I come and do a stage in your lab? I, to my own detriment, often say yes, right? Because you know, having somebody in your lab means taking the time out to show them how to hold a pipette min or pass the cell. But I think that providing opportunities to young people to see what it means to do science day to day is absolutely essential. And yes, whenever I can, I try to engage in these activities.
No, I fully agree. I think, despite, we have to, in a way, be producers of good science, I think a fundamental part of our job is actually starting scientific careers. And if you think of it, or this is the way I always talk about it or think about it, sometimes, it's maybe less important to have your next paper next year to be very, very high if you can devote maybe a couple of years in forming a student that will make and produce many, many papers in the future. So I think in terms of returns, it's probably better to be an educator than being a paper producer.
Yeah, I mean, I don't have a big ego, and so I completely agree. I believe that I like to surround myself by people who are a bit smarter than me, number one, and I think that it's my job to help people on their path to becoming independent scientists, because I don't know the people who pass through the lab. You don't know what you have, like what potential they have, and so I think it's our duty to help form them in the best way possible, to make sure that they have projects which are feasible in the time frame that they have so that they can have early successes, and to send them out into the world, not to maintain them just because they're great and we don't want to let them go. I think it's part of one of the duties you have when you reach the type of level that we're at. And I also do feel like it's an opportunity to give back. I remember being a high school student and spending the summer in a college research lab. A professor invited me after a science fair project that I had on molecular biology. At the time, I didn't know what molecular biology was. I just knew it was cool and very interesting. And so she said, "Kristina, do you want to come and spend the summer? You can do a Western."
Yeah.
And I was a high school student, and I went there, and it was so exciting. Right, and she really she lit a fire, and I think that if you can, in my own little way, I completely agree. It's our obligation to light small fires and hope that they take.
And I mean, I think a nice aspect of what you said is that sometimes the fires are small fires and they start fairly early. I mean, actually, the earlier probably the better. So engaging students that are relatively young is also very valuable. So thank you so much. Maybe I'll ask you the last question, which is the usual question that we ask in this interview is what EMBL meant to you, and how do you see your relationship with EMBL in the future?
EMBL was really a turning point in my life, I think. I've already stated previously, coming to EMBL was really for me like a statement of commitment that I wanted to try to do something in this field, and EMBL provided me so many opportunities, both in terms of not only like scientific evolution but also personal growth, and I will always be grateful to the time and the people who surrounded me when I was here, and I would continue to be inspired by EMBL and the type of research is ongoing, and of course I'd always like to engage with EMBL from throughout the rest of my career. I'm always open to collaborations on any level. Yeah.